Hello, yeah. Hi, very good afternoon to all of you. I'm Yong, and together with me, my teammate Thang, we are from the Grab Data Streaming team, Data Streaming the infrastructure team, and we are here to present to you on what have we done so far to drive efficiency in Grab Streaming data platform. And of course, we are driving this efficiency with our partners, AutoMQ and AWS. So a table of content of what we are going to present today. I'll start off with the background and challenges that we face in our current data streaming platform, and our wish list on what we want to achieve of looking for a data streaming platform, and then the reason why we choose an AutoMQ. Thang will proceed with sharing our journey and the future enhancement. So for the background and challenges, Grab Data Streaming Platform is behind three key areas in our system. It's the entry to our data lake, where we ingest data from our services into our data lake for storage and further analysis by our data analysts. It is also used for real-time event processing to analyze data as they occur and make decisions. Last but not least, the data streaming platform is also in charge of service-to-service communication to facilitate reliable connection between different services, mostly transactions. So with all these three key points in place, the key for our data streaming platform is to deliver and drive high volume, low latency, and highly available data streaming platform at terabyte per hour scales. And this is not an easy feat for us, of course. The challenges that we face is in key four areas in our current platform. We face challenges while scaling our compute and during partition movements. Because during the partition movements that we face spikes while scaling up our partitions, and that actually hinder our operational efficiency. And when the storage needs actually increase because of our business demands, the disk usage between the various brokers are not the same. And therefore, adding storages require us to scale our clusters or scale up the disk brokers on the disk, or scale up the disk on the brokers. When it comes to maintenance-wise, we are unable to optimize our cloud resources. Right? We try our best, but the current provisioning is based on the peak usage. As such, during a low off-peak period, there are actually extra compute resources in our clusters. Last but not least, during our cluster maintenance, we actually rebalance the clusters to ensure that they are in a healthy state. The prolonged rebalancing actually increases the latency of our system, as such impacting our system performance. So because of these key challenges, we then come up with our wish list. We did a retrospective within our team and come up with 5 areas that we want to improve on while looking for a new technology. The top priority for us is to ensure that we have complete elasticity. This is the ability for us to actually scale dynamically during peak and low periods of our user patterns. Next, we would like to be able to meet new growth in our business by ensuring our storage are scalable. As such, we need the storage to independently scale apart from the compute. Next, we want to ensure fast reassignment of large partitions. Some of our partitions are large, and what we mean by large is that it will take hours to even move them. And this will cause our producers or our clients to face high latency. We want this fast reassignment in order for us to actually handle peak periods and get back our latency that we want. Apart from that, we do have a lot of services on our Kafka platform, right? So we want to ensure Kafka API compatibility. Rewriting our codes are not easy feat. So we want to ensure that when we adopt a new technology, we can seamlessly integrate it with our existing clients and our control planes. Last but not least, it must be able to meet our current low latency need. There are latency sensitive Kafka use cases used for machine learning, and when the latency happens, the decisions are delayed. So why did we choose AutoMQ? The earlier presentation by AutoMQ has stressed that they have the capabilities to move into a shared storage architecture. As such, we are moving from local disk to use the cloud storage availability such as EBS and S3. We start off, our current architecture actually is based on replication. As such, the compute elasticity is not that great. When we are moving between nodes, data are actually moved between brokers, and that actually cause what challenges that we face. So with AutoMQ, the data is read from the shared storage, which is across the brokers. As such, the clusters can be scaled easily. We're able to respond flexibility to the user patterns. The storage user scalability is also there, thanks to AWS S3. We are using on-demand storage on S3 storage. When the user needs more retention, the data just grow on S3. We do not need to scale our brokers. We do not need to manually add these storages in our brokers. When it comes to fast reassignment, during a need to actually move the partitions, only the metadata, which consists of which is not the actual data, is actually needed to be synchronized to make a complete switch of a partition between two brokers. As such, we are also particularly interested in the low latency requirements of AutoMQ. We have seen a few solutions across the board, and there is an increase of latency using storing this data on S3 for sure, as compared to local disk, which is a low latency device. As such, the implementation of the write-ahead lock in AutoMQ allows us to achieve block level devices presented to the Kafka processors, and therefore assist in achieving the low latency persistence that we need. Last but not least, like what Sidra has shared, AutoMQ maintains Kafka compatibility, and that includes the reuse of the compute layer code in Kafka and the test cases of Apache Kafka, which makes us comfortable to adopt this technology without rewriting our codes. So next, I'll pass the presentation to Thang to continue on our journey.
Moving forward with our journey with AutoMQ at Grab so far. So initially, during the POC stage, right off the bat, we would like to deploy AutoMQ on Kubernetes, which is our existing status quo of how we are deploying our existing streaming data infrastructure. So we would like to uniformize that and follow what we have done so far. And we have successfully do so in deploying over on Kubernetes, and we have confirmed its viability before moving on to our next step, which is to evaluate AutoMQ as a product and how well it fits to our needs and the wish list that Yong have shared earlier on. So we have conducted evaluation in 3 separate sections. First of all is performance. So we have done benchmarks with different configuration, such as different replication factors or different acknowledgement configuration for producer, and to see how well it suits to our needs. Is there any learnings that we need to get used to, or is there any nuances and niche that we need to be prepared for or to be aware of? Similarly, with reliability, we also conduct test cases and benchmarks for use cases such as failover, or when there's failure to the instances, to the infrastructure, be it gracefully for test scenario for planned maintenance, or something more disruptive when there's unexpected failures. And lastly, for cost effectiveness. So in this stage, our goal is that for any product that we are evaluating, we are prioritizing performance and reliability. Cost effectiveness, as long as it's not worse off as compared to what we have so far, is good. And thankfully, AutoMQ has passed all of our benchmarks and test cases, and we were confident to move on to implement and putting into real use cases that we have over at Grab. But lastly, before we are confident enough to deploy over in our production use cases, we also put in some development use cases into an operator on Kubernetes. So currently for our streaming data infrastructure over at Grab, we use Streamzy as our Kubernetes operator to operate our maintenance deployment for our clusters. So similarly, we would like to uniformize the effort and standardize our deployment methods and operational aspects. And we decided to put on development efforts for Streamzy operator to support AutoMQ as well. So in order to do so, there are a few features that is specific to AutoMQ that we have to put work into our Streamzy to support it. So first of all is write-ahead lock volumes. So as compared to a normal cluster where we have data volume mounted as file system, for WAL volumes we have to mount them as block device. based on the architecture of AutoMQ. So with that, some features that we need to support, which is to create the volumes as well as the volume device mount as compared to the file system mount on a normal cluster when the operators being brokers or provisioning the cluster from scratch. Additionally, we also have to update so that the Kubernetes deployment gives sufficient permission to the containers so that they have sufficient permission to read and write from those volume devices that we created for WAL volumes. Second of all, StreamZ itself also provide container image view for existing application, which is Apache Kafka. So when we plan to support AutoMQ, we also needed to update those process and add on the support for AutoMQ container image view as well. And moving on to some learnings that we have in AutoMQ so far. So even though it's fully compatible with Kafka and subsequently fully compatible with the entire stack that we have been having so far, there are still some learnings that we need to familiarize ourselves with, because there are still some AutoMQ specific knowledge that our engineer need to be aware of. So those are monitoring metrics. So now that AutoMQs are as an application writing to S3 as well as writing to volume such as the volume device backed by EBS. So we need to monitor those metrics. We need to familiarize ourselves on what to monitor, what are the nuances, how spiky can it be during peak periods, for example. And there are some other things such as AutoMQ compaction metrics that we need to familiarize ourselves in similar fashion as well. Additionally, as we utilize AutoMQ, we have been moving towards a new horizon of things that we have never experienced before in a good way. So, for example, we are now more tolerant to frequent partition reassignment. So we can trigger rebalances more frequent. We can tolerate more disruption. So from the infrastructure side, we now support that. So similarly, in our clients, such as producers or consumers, we need to be able to tolerate those as well. So we have made some changes, such as implementing back-off retry for a longer duration, for example, so that we can handle more frequent partition reassignment. Or now that AutoMQ can handle higher throughput within our fleet, then we also need to optimize our client to batch the messages so that we can achieve a higher throughput overall in our platform. Now, to talk about some improvements that we have managed to achieve in our platform by utilizing AutoMQ. So there are three things I would like to go through. First of all is we have managed to observe a boost in throughput, because with data replication moved from interbroker to cloud-based storage replication, so we have managed to reduce a lot of compute usage, and thanks to that, we have managed to see a 3 times increase in throughput per CPU core. And similarly, since we are using the same compute capacity as compared to other existing clusters that we have, AutoMQ is now one of the largest cluster in terms of throughput within our platform feed. And also thanks to that, we have managed to achieve better cost efficiency as well. So initial figures show that we have managed to achieve a cost efficiency improvement of 3x with more room to grow, because we have been prudent in deploying AutoMQ within our fleet. As similar to any new product that we introduce to our infrastructure, we are more reserved. We will be over provision the cluster so that we can tolerate any unexpected spike, for example, in expectation of anything that we are not aware of during POC or evaluation phase. And lastly, we also managed to achieve a more efficient partition reassignment. So for the entire cluster, every time when we trigger a rebalance, for example, that will subsequently trigger a partition reassignment among the brokers. Now for the entire cluster, that takes less than a minute as compared to our existing fleet. Some of the cluster that it might take up to 6 hours for this kind of operation to finish, which is quite costly for us. So some of the operation such as scaling brokers. Now that we are moved towards the shared storage architecture with AutoMQ as compared to shared nothing, as I mentioned, it takes very fast partition reassignment. So per partition reassignment, it takes seconds level. And thanks to this, it also enhances stability for our brokers, because now there are no data to be replicated among brokers when we move the partition. So there will be no surge in I/O as well as network utilization. No data to be moved among the brokers. So it is more stable and it's more, no more spike for our operations. And lastly, because the reassignment is very fast, so it also, in a sense, reduce impact to a client, because now we no longer observe any prolonged latency increase for both of our producers as well as consumers to the application. Similarly, thanks to the shared storage architecture, now we can independently scale our cold storage. Previously, when there's a need for us to scale the storage, we will have to either provision additional brokers to the cluster, or scale up the storage on the per broker basis. So that not only increase cost for us, because when we provision new brokers, there will be unneeded or underutilized compute capacity that we don't really need, or as well as when we scale the cluster, we will need to trigger rebalance. So that also increase latency for both of our producer and consumer client, and that also affect our stability. So we have managed to benefit from that in that aspect. So lastly, I'd like to go through on some of the future enhancements that we are looking to further enhance our fleet. So first of all, we would like to look into further enhance our utilization efficiency in terms of compute capacity, because there are another feature baked into AutoMQ that we have yet to utilize, which is called Auto Balancer. So it's something similar to open source product called Cruise Control that people often use with Kafka. AutoMQ Auto Balancer will trigger rebalancing as needed periodically, so that our compute capacity can react better both during peak and off-peak periods. Secondly, now that we are able to tolerate more frequent disruption, as well as it's not as costly anymore, or it's quite negligible for us to perform partition reassignment, we can look into auto scaling. So during peak periods, our cluster can scale up, and subsequently during off-peak or low periods, we can scale in, and it will further enhance our utilization efficiency, and subsequently cost efficiency as well. But in terms of cost efficiency, there are a few other things that we are planning to do to further enhance that. So first of all, is we are looking into reducing our cross-AZ traffic between clients and brokers. So for this, we are looking into utilizing what is called rack awareness for both producer and consumer end. And yeah, so as I mentioned previously, we are now more tolerant for disruption. So we can look into EC2 spot instances so that we can realize some of the cost saving on that aspect. And as you introduced earlier on, AutoMQ now support table topics, and we are also at REP, we are also planning to look into that so that we can reduce the redundancy of some of our data syncing pipelines that will be no longer needed as we introduce table topics into our use. And lastly, since AutoMQ has been working so well for us over at REP, we are looking to further the adoption and migrate more of our use case over to AutoMQ. And yeah, that concludes our presentation. Yeah. Thank you. Now I'll move over to Q&A if anybody has any question for us.
You can reach out to us on LinkedIn or the networking session later if you have any question on our implementation in our.
Thank you, everyone.
Thanks for your time.
Cool. Thank you to the Grab team. Yeah, that was fantastic. Thank you, Jerry, for taking time out of your day and sharing reInvent updates. It was an absolute pleasure hosting all of you here today. If you would like to join us for a community photograph, we'd like to just take one outside the room, up against the AWS logos against the wall. That would be brilliant. And there's a bit of food, some drinks, hang around, network, get to chat with some of the guys from Grab and AutoMQ. It'd be great to meet you and do a bit of networking. Cool. Thank you very much.